Okay, so we said the answer to the bell work was, what was A? Oh no, was B. And then A. So today we're going to talk about ternary nomenclature. So ternary, it means that there is going to be more than two compounds in there. So these are usually going to be polyatomic. So that means memorizing those polyatomics is going to help you out. So what is the name of this one right here? Ammonium nitrate. And what about KNO2? Potassium nitrite. And let's go to number CuCO3. Copper 2 carbonate. Looking at those, do you guys have any questions? Do you need me to fill out the rest of them, or are you guys good? HG2O would be mercury. I think it's mercury 1 oxide. Mercury 1 oxide. Let me find my notes real quick. Yes.
For the NaHCO3.
NaHCO3, yes.
I know. Yeah. It's a sodium dicarbonate. Yeah. And I was like, that should not be that. Why did it say that molecule should be sodium dicarbonate on the whole key?
It was the exact same one.
Yeah.
I am not sure. The key might be wrong. You will find mistakes in the key. But it should be sodium hydrogen carbonate. So I'll look back on that and see if it can be both. Because sometimes you're going to see that they name them weird. That sometimes, you know how we'll say copper 2 carbonate. Sometimes they'll come through and or say potassium nitrate. Sometimes people will put the dis and the tris in there. Naming is so weird because people do it different ways. One book will do it one way and one book does it another way. But go ahead. Okay, so let's go to the next one. Lithium carbonate. What is the formula for lithium carbonate? Lithium is a +1, carbonate is a -2, so it would be Li2CO3. Magnesium hydroxide. Magnesium's a +2, hydroxide's a -1, so our formula is MgOH2. Lead to permanganate. Lead is a +2, permanganate is a -1. So our formula should be PbMnO4 2. It should be chloride, yes, thank you. No, chlorate. Chlorate. So it would be chromium's a +3, chlorate's a -1. So CrClO3, 3. Anybody have any questions on those? Want me to do the other 4 over there? Speak now. All right, I'm going on to the mixed. What is the name of Na2SO3? Sulfate or sulfite? Oh, this thing keeps. FITE. What about SCl2? Sulfur dichloride. What about CrPO4? CrPO4? Chromium, what? What's the charge on chromium? 3. So it would be chromium 3 phosphate. And what about MnO2? Manganese. We know it's manganese oxide. How many manganese? What's the charge on manganese? Don't look at the periodic table. What's the charge on oxygen? Oxygen's always a -2, and there's 2 of them. So total of -4. So manganese charge has to be +4. So it's manganese 4 oxide. Questions on that? Any other ones of those you want us to do? Yes, Lauren.
Since this is sulfur, SO3 is acting as a magnetic compound. Do we skip?
So it's SO3 is sulfur trioxide, but SO3 is what? Sulfite. Okay. All right. What about any of these you guys want me to do? Just want to pick one. Osmium 8 oxide. Osmium's a +8. Oxygen's a -2. So it would be OSO4. Yes.
Peroxide is just O2, right? So it wasn't on the AV chemistry that they're atomic list?
It wasn't on there? Peroxide is O2 with a -2 charge. So this would be Na is a +1, and this is O2 with a -2. Na2O2. And then I'll do copper 2 phosphide. So Cu Copper is a +2. Phosphorus is a -3. So Cu3P2. Questions on those? All right, let's go to the acids. All right, acids. So here in one of the acids we have HCl and H, which is gas, and HCl, which is aqueous. So when it's a gas, it's just going to be called hydrogen chloride. Whereas if it's liquid, then it is hydrochloric acid. Bless you. All right, so remember back, and I don't know who all your teachers were, but remember when we were talking about acids, if it is just an H with a another compound, it's binary, or another element, it's binary, and it's just going to be hydro, then the root, ic acid. Whereas if it is a polyatomic, then you have to go to your rules, and I always remember it as ic. I ate a humongous bite. If it ends in ic, you change, or if it ends in ate, the name goes back to ic. And if it ends in ite, the name goes to us. All right, so perchloric was perchlorate. So ic, I ate a humongous bite. So ClO4 is perchlorate. Perchlorate becomes perchloric acid. CO3 was carbonate, and now it becomes carbonic acid. SO4 was sulfate, and it becomes sulfuric acid. One thing I do want you to see is that, I can't write it up there, let me see if I can change a different color here. HClO. ClO is hypochlorite. Sometimes you will see this written as HOCl. Same thing. And then H3PO4 is phosphoric acid. Any questions? H2SO4 is sulfur S. So ic, I ate a humongous bite. Hypochlorous acid, yes, HClO. Or HOCl. So what's the formula for hydrosulfuric acid? H2S. What about nitric acid? HNO3. Hydrocyanic acid? HCN. Puritic acid, this one is weird, I had to go look it up. H5IO6. Oxalate is C2O4 -2. So oxalic acid would be H2C2O4. Hydrobromic HBr acetic is HC2H3O2. And phosphorus, H3PO3. Are there any questions on those? Okay, so let's start in with the average atomic mass. So remember, an average atomic mass represents all the isotopes, the average of the isotopes and their percent abundance. So what we do is we are going to take our mass, the relative amount of mass, so mass, and we're going to multiply that by the percent, or we're going to change that to the decimal. Of percent abundance. And then we're going to add all of that mass times percent and however many there are, and we'll get our answer. And we're going to stop right there. We're not going to go any further. So here in this next problem, we have find the average atomic mass. So our relative mass is 19.992, and we're going to multiply that by 0.9092. We're going to add that to 20.994 and multiply that by 0.0257. And lastly, we're going to take 21.991 and multiply that by 0.0882. So put those in the calculator and tell me what you get. $20.639. 20.639, and our units are U's, or you may see it as AMU's. And it comes out to be pretty close to what's on the periodic table. Here's one where you have to find the mass of the other isotope. So how can we do this?
You could find out, you do 0.7577 times the mass of the 35 CL, and then use the other variable as x, so that plus x equals whatever's on the periodic table.
X times the amount that we have, which is 24.23%, or 0.2423, and set that equal to what's on the periodic table, which is 35.4527. So put that in the calculator and tell me what you get. $36.966, and our units are AMUs. Any questions on that?
Oh.
Yes.
Where did you get the 0.2423?
Because we know 75.77% of it is chlorine, so the other, takes me up to 100%, would get me that other percent abundance. So 24.23%. So we go on to next is 1 and 2 step mole calculations. So we're going to talk about molecular mass and going from mass to moles, and then taking it one step further and going to molecules. So I'm just going to let you guys do the reading on that tonight for your homework. You have your homework assignment. Do your homework assignment all through the percent composition or percent average atomic mass, and then just stop there, and then I'll just assign the rest of it tomorrow along with the molar mass and mole calculations. Are there any questions?